In this video, we will demonstrate how large amounts of energy can be conserved in residential areas, consumer products, and in various industries. Until recently, energy conservation was never a major consideration as it relates to most products.
Approximately 60% of the energy used in the United States is through induction motors. At least that's one of the statistics that the Department of Energy threw out years ago.
It would be safe to say that most users of induction motors do not know how efficient their induction motors are. As a result, very few realize how much energy is lost due to improper use and design deficiencies.
The users of industrial energy know very little about how much energy they're consuming. I challenge any person to walk into any place, machine shop, home, or what have you, and ask them for how efficient their motors are, and they don't know.
Induction motors were designed and configured to ensure that they will operate at low line voltage. In order to save wasted energy, all induction motors should be controlled to operate at 90% of the nominal voltage of 120, which is the supply amount to most residents and businesses. Since most products are designed to safely operate at 100, any voltage above this level can be considered excess energy. Reasons why induction motors consume excess energy. 1. The electrical motors are sold in fixed frame sizes and are frequently oversized for the application. 2. An electrical motor is selected to safely drive the maximum peak load but is excessive for normal load operation or varying load. 3. Motors are designed and configured to ensure that they will safely operate at minimum low-line voltage. The solution is V2R's patented dynamic motor controller, which safely delivers the minimum required power to a load regardless of load variations.
V2R's product basically operates the induction motor at the low line voltage. It reads the load. If there is no load, it's operating at the lower voltage. But then when the load needs more power, it asks for it and the product delivers it.
We have two voltages. One is 120 volts and the other is approximately 96 volts or 92 volts. And we can, on a cycle-to-cycle basis, we can switch between the two. And as we switch between the two, the circuit sees what we call an average. In engineering, we call it RMS value. We can operate at 120 volts, we can operate at 115 volts, we can operate at 110 volts, we can operate anywhere during the range. What determines that is our software program. For our demonstration purposes, we picked only a couple of points, but we could have 7 or 8 points of energy levels in between the two.
The V2R controller can potentially save up to 30% of the electrical energy consumption in a variety of induction motors, making it one of the most cost-effective, efficient, and easiest means of conserving energy today.